Welcome to today's meetup, Cloud Transformation to GCP. My name is Eric Forslid. Oh, sorry guys. My name is Eric Forslid, and I'm a business unit manager here at Forefront for a unit that focuses on system development. And as you can see, I have company with me here today. We have August, Philip, and Daniel. And you will have the pleasure of listening to August and Philip's sessions later. And Daniel is here because he couldn't resist joining this panel when I asked him. But let's make a quick presentation round. And so tell us who you are and what you focus on during your days at work.
All right. So my name is August, and I work here in our solution architect team. And I would say I work with a bit of highs and lows. So my topic today will be a bit more about business architecture maybe, but I also want to dive into the technical parts and more traditional solution architecture work, but try to stay with a kind of modern approach to technology and ways of working.
Great. Philip?
Yeah, my name is Philip, and I work here as a data scientist. I work both with advanced models and data warehouse building and different kind of tools. And right now I focus on Google Cloud for my current project, and I've been doing so for a couple of months.
Yes. Thanks. Daniel?
And my name is Daniel Olge. I'm working as a solution architect, mainly within the banking and the retail industry, working with integration problems. I come from a technical background, so I have a big interest in deep dive technology, but I tend to work in both the detail level and on a higher level as well, depending on the case.
Yes, great to have you guys with us tonight. But before we start the sessions, I would like to give a presentation of Forefront. We are quite a big company nowadays with about 400 employees, and we are organized in 3 different areas where we have management, which main focus is business agility and enterprise and business architecture. And then we have channels that do more of design and user experience related stuff. And then we have technology, which mostly stands for the presence here tonight. But what we do in technology is quite a wide scope. Obviously, we focus on technical development. And tonight we will talk more about these highlighted areas. Of course, Google Cloud Platform, including Bigquery and analytics, and then we will have talks about platforms and Kubernetes and event streams and Kafka. And but to make the most fun with our days, we focus a lot on teamwork and innovation. And one of our strongest beliefs is that the team is more than the sums apart. I don't know who said that, but I think it's a great quote when it comes to describing the powerful strength of a really good teamwork. And this philosophy is something we are aiming for on an everyday basis and is shared among the partners, customers, and speakers here tonight. And on the theme of innovation that we are really passionate about, we are tonight going to talk about moving analytics to the cloud, possibilities and benefits with that, and also faster feature to production cycle and the area around an event-sourced integration architecture. But to move fast and to be competitive requires always, at least in our mind, a trade-off between value on one side and learning on the other side. And this trade-off is important so that all the fun technology really creates value in the end. And when it comes to implementation, we mostly focus on the implementation layer at technology, but Forefront as a company do implementations at the other levels as well. And that's all about Forefront. And this evening is done in collaboration with Google that we are partner with, and this partnership have now lasted for 2 years, and we are really looking forward to extend and expand this relationship ahead with you. And Google's mission is to enable organizations around the world to transform their businesses using digital technology. And this rhymes a lot with the mission that we have at Forefront, that is to guide organizations through the digital landscape. And we also have our friends from Stackater with us, and we do a lot of work in collaboration with them, and Stackater's main focus is Kubernetes-based infrastructure. And a quick view at the agenda after the welcome and introduction step that will be followed by August sharing his experience from academic work with the title A Data Culture for Everyone. And then will Micke, Philip and Christian give their key takeaways from helping organizations moving analytics to the cloud. And after that, will Per give us his 6 steps to success on Medmera Bank's journey to become an event-sourced bank. And finally, Rashid will wrap up with integration modernization, and techniques in focus will be Kubernetes, Kafka, and Apache Camel. Yes, and all the sessions are pre-recorded yesterday, and the reason for this is the current Corona situation. And so I would like to, and after each session, after each session we will have a Q&A. So I would like to encourage you guys to ask questions in the comments field as they pop up to you, and we will address them in a live manner afterwards. And since this live stream setup is quite new to us, this is the second time we are doing it. We are elaborating a bit with the setup to give you guys that are watching the best interactive experience as possible. So don't hesitate to send us any suggestions on how we can improve this type of events in the future. But some game rules for tonight. The presentations are pre-recorded, as I mentioned before, and speakers are available for Q&A in some format after each session. We have 2 speakers with us here tonight, and Daniel is here because you are an expert in the field of Kubernetes and Kafka and other integration-related questions. And the other speakers that you will watch tonight are watching the live stream as well and are happy to answer your questions directly in the comments field. And if you are interested in any of the presentations material, then we are happy to share that with you. And we can also arrange individual sessions afterwards or at another time if anybody is interested in that. Just send me an email at eric.forslid@forefront.se and I will help you with that. But now, let's have some fun together. And I think we start with the first session. That is you, August. So over to you.
All right. Yes, I guess we just play it. All right, so I'm going to talk about a topic called data culture for everyone, and with the help of event storming and domain-driven design. So first of all, I will introduce myself a bit, and my name is August, and I've been with the Forefront for 3.5 years, and I'm a part of the solution architecture team here, and in our work, we try to do more of a team-driven approach to architecture, trying to move away from the more old-school ivory tower kind of style. And also, as an architect, I truly believe in working with just enough the structure in order to get forward and deliver value. and also just the doing part is very important for me, and not just drawings and models. Also right now, just for you to get a bit of sense who I am, I like working with domain-driven design, as I do in one of my largest projects right now, and also with event-driven architecture, and also looking a bit into graph technology, which is something that I find is very interesting. So for today's topic, I will speak a bit about the data culture as I define it, and so a bit introduction to what that is. Most of today going to be about Google Cloud Platform and how to leverage the cloud technologies. But in order to do that properly, we need to have first and foremost good data, but also a culture where we know what data is and how we're going to use the data. So I think this comic strip is a kind of good summary of one of the many problems that we can see at many places, that, okay, we have a lot of KPIs, we have a lot of information, but we don't really know what they're all about and how we're going to use them. So then it doesn't really help us to have a lot of information. So in order to solve this, we have the common abbreviation that's called GIGA, and that's garbage in, garbage out. And that's just like a common principle when you work with data and analytics, that if you don't have clean data to work with, well, the results, they won't be that good either. So in order to combat that, we need to be able to take advantage of the data we got in a more meaningful ways. And we need a collaboration between the business that works with the processes creating data and that use the data in their work, and the developers that take forward the data and create the KPIs necessary. So it's really about the collaboration in essence. And one way that we can create a better collaboration in order to have better data quality and better understanding is the topic of event storming. And that's what I'm going to speak about mostly today. So event storming is it's a workshop method or a tool that you can use to explore the business or a business process, and it's done in a very light and agile way. So therefore it's a very good tool to have under your belt and to do if you want to understand something and to lay the basis for a data culture or a data collaboration. So this is me doing an event storming session at one of our customers, academic work, where we have done a lot of these and we have been very successful. So I want to tell you more about that. So as you can see here on the pictures, it's a very analog method. It's about post-its on a big canvas, but it's actually quite valuable. And I will now introduce you a bit more to the method itself. So let's get into it. So event storming then. So as I mentioned, it's a workshop format and it's good for quick exploration of complex business domains or value streams, you could say. And how you do one is that you need a modeling surface, and that's basically a blank canvas. You can use a piece of paper and put it up on your wall, or you can have large whiteboards, etc. But basically a large space. And you really don't want to be constrained by the physical space. If you get constrained by the physical space, you also get constrained in your thoughts, and you try to like squeeze in things just to fit it to the physical space. And that's not good. So this is actually one of the common problems usually. You should have a lot of space so you don't get constrained. And then you also need sticky notes, a lot of them, and mainly orange for this first part, but also a piece of pencil. And for everyone to be able to collaborate, a good visible legend with how you do it is also good as a baseline. And then you know seats in sight, and you will have basically a standing, more moving workshop format. So this is like the prerequisites of why you're doing it. And I will get more into like the whys and hows and like the effects on it. But basically this is an event storming, what you're gonna need. And as many similar modeling techniques. You have more classic ones like UML or BPMN that architects usually use when you want to flesh out a process or understand a system or something. That can be quite good, but usually the ones that understand them is only the architect, like him or herself, and it's not really useful as a collaboration tool or when you're going to show anyone else. So this is a much more lightweight process that everyone can both participate in and understand, which I think is very, very, very good and useful. It looks like something like this. And it was created by this guy actually, called Alberto Brandolini. He's an Italian, and he came up with this idea when he was doing a lot of domain-driven design, and he was just trying to like show his train of thought basically, and he wanted to be able to collaborate on domain-driven design with his peers. So he invented this model when he had a piece of canvas in his backpack, and then it just has developed from there. And there's also a good book by him available online, and a little of the content here is also from his material, which is very good. And there's also a good of YouTube videos that you can watch him explain it a bit further after this. But basically, he says it's a platform for collaboration, not a rule-based system. And that's also important to have in mind. So before we dig down even more into the use cases of event storming and how you're going to do it, just want to give you a bit more context in what it's coming from and where you can go with it. So if you're not familiar with domain-driven design, it's a concept, or it was actually a book written by Eric Evans in 2003. So it's not really something new, but he's been around for a lot of time, but had a more or less a little revival in the last couple of years with microservices and event-driven architecture, where it fits actually very good. And one of the main concepts here in domain-driven design is the ubiquitous language. And the ubiquitous language is a common language or a understood language between the technical experts and the domain experts, the business experts. And why this is so important, especially when you're talking about data and analytics, you need this common ground in order to collaborate. And I think the ubiquitous language is a quite good term for creating that. And when you can have this understanding, you can much easier develop the right type of analytics, dashboards or KPIs or whatever you need that actually makes sense, that you do understand. So this is basically the foundation of having something useful that you can put in your new tools that you can have with the cloud technologies. So building upon domain-driven design then, if you're going to do an event storming, you will use a lot of the common principles and building blocks of domain-driven design, but in this workshop format. So the reasons for doing this, like what you can get out of it, is quite a lot actually, since it's more a platform of exploration than it's for this purpose. So you can tweak it and twist it a bit to your own need, but these are some main use cases, and I'll also explain how I have used them and how we have been successful using them at academic work. But basically, these are the four main topics. So the first one is improving your organization. So maybe you have a value chain or a process or process line of some kind, and it maybe has a system or several systems that supports it, and you want to optimize it. And then you can just gather the participants of that product line and do an event storming session in order to find the good and bad stuff basically. So you can dig into the business flow and model basically the entire line. You can uncover a lot of inconsistencies and competing goals and other perspectives that you might have not realized. And also you can highlight the key impediments to value creation and value delivery, which is very good for optimization. So as you can see, the event storming process will help you build this narrative and also focus your efforts on where you can do the most difference. So that's one of the points, like effectivization of a current or like existing process or system flow. If you're more like greenfield approach, you can use it more as a like describing your landscape. So you want to like model a new ecosystem, you can use this as a good canvas to start out. And you can also create like a storytelling between your business vision and your system to support it, which is very good in the early stages. And also highlight like the architectural boundaries or bounded contexts of the new system in order to like size it and the correct way, you can say. And the two other common use cases are just if you want to develop new services, you can use this as a collaboration between the key stakeholders, and I will go into more the details who should be involved, but usually it's the development team and the representatives from the business. And you can then support the different cross-discipline discussions together with this language, which helps you in the collaboration. And since you like model everything that's happening, you also have the different perspectives and handovers, which is quite good. And also, which is kind of interesting with this, you can take it from the most high-level view even down to actual like software design. So even if you start out with maybe just like everyone that just use the system as of now, like generic business users, you can then like improve upon your model and then break it down into smaller groups, and then you will actually have sort of the requirements there for you to actually build your system upon in a quite high amount of detail, which is very good. So in order to summarize a bit, there is more a platform of discovery than a specific tool or use cases. So it's very flexible. So you can use it and tailor it towards your needs. Then again, I think it's always important that you should have like, you should know what you want to use it for. You shouldn't just start using it, even though you might have some good ripple effects. You might find the good stuff out of it that you didn't expect. I mean, you should have a purpose. You should do it for a reason. When I did it at academic work, we used it more as the platform for discovery of our new system that we're going to build. So we were building a new greenfield like system landscape, and we wanted someone to capture both the business representatives and the developers and get everyone together. So we used it there and then as a starting point, and then we iterated on that later. So we used it a lot, but we started when we wanted to like start a collaboration. So these are some of the use cases, and there are of course more, and there might be some discussions regarding this in the studio panel afterwards. But if you then look at it, you can break down the use cases down to mainly 3 different versions of it. So the big picture is usually done with like less technical people, and you can gather everyone, and you only work with basically events, and you just try to capture a narrative of the business. And then you can drill down and you have a little like more narrower group towards the more technical stuff. So when you're down to software design, you add a lot of notations into the model, and then it gets more technical and more detailed, and then you don't have to be as many. So you take something big and then you drill it down in more detail. So before I tell you exactly how to do it, this is my view of how it looks at many organizations today and what event sourcing can help you with. So if you do the big picture event storming, which is a good starting point if you've never done this before and you want to try it out on like existing process or workflow or something new that you're going to build, this is usually how it looks like. So you will have a shape of the organization, the people involved in the sort of value stream that is made out of, if you're at least a bigger company, several different departments or groups of people, and everyone knows like their expert area very good. And there's a bit of like common saying that if you're a IT person or developer, you don't understand the business. And it might be true in some senses, but also it's kind of true that like a lot of parts of the business really don't understand the other parts of the business. They more understand their own part very, very good. And this is usually quite revealing when you do this event storming workshop, that you find your different like gaps of knowledge distribution. So when you try to map out the whole process or value stream, you will find that, okay, who does this part? And it's usually just one or two guys, or no one really knows, which is kind of interesting. So it's kind of good for just like aligning what you're actually doing and just finding the gaps in that as well. But what's good here then, when you gather all the persons, if you're doing this big picture one, that is a value stream, and you have people from the business, that's from different departments, they will be like forced to like fill these gaps and create this narrative together, which also brings people together, but also helps finding these areas, and might be sometimes quite a lot of tension between like groups if there are conflicts, but that's good to like address those early at least. And what you will do, sort of the main point of the whole event storming, is you will create a business narrative using business events. And basically all the events will be represented by these sticky notes and be something that happens in the business. So once you're done, you will have the story of the business, and it will be like the complete story, everything that you have that's important, and you will have worked upon it together and incrementally. And that's really powerful as a result, that you can see, okay, we did this, we created this, and this is actually it. And usually it will be a lot of aha moments for everyone that's participating. And you also can address these conflicting areas. And if you're a developer, usually your role will be a bit more passive in the initial stages, since you will observe and you will more or less like listen in. You need to learn the business in order to create a good system support for it. And therefore, I mean, this is really valuable for you, and if we're like both if you're a developer or user experience designer or something else, I mean, this is the goal that you want after. So you can take like a bit more passive role, but also like ask your questions and help the business out to model the process together. So this is what you can use it for, and the main concepts. So a bit more detail in hands-on, like how you're actually doing it. So it will basically be done by placing domain events, and this is for the big picture workshop where you only use mainly this one notation. So an event or a business event or domain event is something that happened in the context of the business. So an example here, maybe in an e-commerce store, is an item added to cart. That's something that happened in the business. And you use orange stickers for this. It's very important to keep the consistency in color coding. And then you always write it in as a verb in past tense. And this is also important because it makes the whole exercise a lot easier. Because if you're just writing something as like in the present or a question, you always will have like a multitude of different alternatives to that. If you want to change something, well, then there can be a lot of different outcomes of that like action. But if you model it as something in past tense, it has happened, then you know, okay, exactly this has happened, and then you can take a proper follow-up action on that. So it's much more easier to build this storyline narrative from it. And it should also be relevant for the domain experts. So these are business events, not database loose connection or something, or it's really like something relevant that happened in the business that moves a process forward. It's not clicks, it's something you do to move a value stream forward. So some more examples. So from the domain I've been working in the recruitment industry, you could have an employee onboarding completed. Okay, that's important for us. And then you can use like the middle out, so you don't have to start from the beginning. Like in order to onboard someone, you can have a job advert published. And then maybe in between that you have employee hired, and in the end you need some time to be reported. So these are important like business events formulated as a verb in past tense. And some not as good examples that you will also find when you do this in the beginning, and it's not, I mean, you shouldn't go around and point this out to people because you want everyone to participate, but you should avoid phrasings that are general, that's not really past tense, like publishing, job advert, employment, update employee. Okay, maybe like employee updated could also work, but you also want to avoid like these CRUD terms, like create, read, update, delete. You want more context, like user registered or contract drafted or contract signed, not like create if it's not really a create event. So you want to capture really the wordings of the business, and this is also central in the domain-driven design concepts. So you can try to do it as properly like semantics as possible, but really that's not it's not the most important part. But in the end then, when everyone's instructed to do this, you will have everyone writing these key events in the domain on an orange sticky note, in a verb, in past tense, and placing them along a timeline. So the timeline here is the canvas, and it's not really the calendar time. Like this is what I do on Mondays. It's more like the cause and effect type of time. So all the things that happened before will be to the left, and the things that's consequences after will be on the right. So you will maybe start at some sales or order placement or something like that, dependent on your business, and work through the offerings and maybe the payments and fulfillment or whatever it is you're doing. But sort of that's the timeline you want to have as a guide when you're placing all the events. And in the beginning, when you do this, it will be a bit. People will be a bit afraid, but they will soon catch on, and just start placing good stuff. And after a while, you will have a lot of events. So usually what you will see is that you will have everyone that maybe have written the same things or in the wrong order. So after 15 minutes or so, when everyone, as you have a substantial amount, you can start to reorder this and sort of like bring order to the cows that you've created. And you can remove duplicates and try to like focus them on structure, not putting up more stuff. And this is also really important for finding these gaps and really fleshing out the real timeline. And also you can use like pivotal or key events to do this. Maybe you have like an order or a invoice or a customer that has registered some key parts that you can use as markers for you to structure your work around. And this is also like, when you've done this, you're more or less in the end of this big picture workshop style. But one thing that's very good to finish off with is doing some form of either dot voting on problems and opportunities, and then you take like red sticky notes for problems and green for opportunities, and you place them along the timeline, and you can vote on the most important problems or opportunities. Or you can do like a value creation and value destroyed, which is basically similar, but you will look at the timeline and see, okay, is this really adding value or is it destroying value? And then you go through that and then you can vote also. So in the end, you will have some like pointers on, okay, this is actually like the good stuff, the bad stuff, and this is the most important stuff, the things that you need to fix the next day. So that's also really good. And also you would have like gained a lot of like knowledge of just learning, and also probably met new people and understood the perspectives of the other ones, maybe in an adjacent process or handover line. So when we did this, it can look something like this. So you have the blank canvas, and then you have a few of the notes, and then you start to get a bit more, and then you will have a lot. And then you have to structure this. But you will basically have the story of the company or the process line on the whiteboard, which is super like interesting and really cool. And in these times, also gotten the question like, can you do this remotely? Yes, you can. We've done this using a tool called Miro. And it's a very good like whiteboard tool. So we've both like done these sessions in remote, but also used it to digitalize the physical versions. And really like the artifact that you do create, maybe that's not the important part. It's sort of the conversations, the learnings that you do in the workshop, but you can do it as a reminder to go back if you want to, and maybe like detail up in small parts. But usually we'll find, okay, the key findings we like or takeaways during the workshop, that's the important part. So I can definitely recommend doing it both digital and online. No, not digital and online, but digital and in person. And if you're going to do it with a lot of people, I would not do it online because it will be hard to capture conversations, but you can try it out. So here you've seen mostly these orange events and also maybe some red that is problems and green that's opportunities. But if you do the other parts, not the big picture, like process modeling or software design, you will introduce more concepts. And I will not go through all of these, but for you to have seen the whole part where you can like use in other areas, especially if you're doing software design and you're actually building like event, domain-driven design, event-driven or event-sourced systems, this is really important. And then you will have these commands, these aggregates, external systems, domain events, read models, user interfaces, actors or people, policies or reactions, and then you will have a command again, so that it will start over. So this has been a like short introduction to event storming, and maybe you have at least like gotten an intro to how we can use it, how can it help me, and I hope you found it interesting. But to summarize a bit, I would say that, I mean, it's a good starting point if you're out in a new project or initiative, you want to do something new and you're looking to use, you want to have good structured data, you want to create the foundation of good collaboration between the business and developers, and you want to have good understanding of your data and like actually create the basis for good quality data. And it's a lightweight and easy, and it's not like you should have a purpose, but it has a lot of use cases. So you don't have to think about too much. You can just try it out and see if it works for you. And then like the domain-driven design and business events is really good for both having as a source of data in a data stream or messaging system, but also to capture semantics of the business and the intent in the implementation itself, which is really good. And then I would say that like having this understanding between developers and the business that you can do with business event storming, and domain-driven design is really good and sort of the foundation for using like good analytic platforms, machine learning, and other technologies to the full extent. So that's everything for me, and I hope you found it interesting. Thank you.
Yes, welcome back, and thank you, August, for the presentation. We have now received 2 questions here at the comments field, and I propose that we start with them, and then let's see if Daniel and Philip have something, or you, if you would like to add something to your presentation. We have a question from Max. Do you have any example of how event storming can be applied to doing the right things? What should be core business and what is less critical support services? And where should we focus our learning?
All right. Yeah, I think it can be quite useful for that, since, I mean, one of the things you actually do is that you map out like maybe a whole business line, and it becomes quite apparent like what you do like in the business, like you have all the parts there, there's nothing missing. So for you to, when you have done the session, just go and like circle the areas which you think is most important, that's quite easy to do. So you can both divide it in like core business, not core business, like this is a bounded context for maybe the sales, this is for the operations or finance. So it's very easy to like circle activities in like a physical way because you have everything there. So I think we've been using it like that, and it works quite good. And I think like one of the strongest things is that usually like IT and architecture is quite invisible since it's covered in like the code and technology. And one good thing here is that you make it visible by just putting it on the wall and then like just discussing around it and like just using it as a tool however you want is quite good. So I think you can definitely do that. And one of the suggested like use cases from Alberto Brandolini, which is the creator, is just like envision the startup landscape and core businesses. So that's absolutely something you can do.
Yeah. Thanks. We also have another question from Björn. I guess event sourcing is a bit too collaborative to be suitable in these corona times, but otherwise it looks, it might not have been a question, but I think you answered Björn's
I
comment.
mentioned it quite, I think, a few minutes later, but I can address that again. So, I mean, we have done it in person, and it's a like social exercise in general. So, I would say like, if you're going to do it with a large group, you should definitely like wait until you can do that when you're back at office, etc. There are tools for making it in a like digital way. You can use like online whiteboard solutions. We used one called Miro, and it works quite good. You have like the sticky notes there, and you can set up everything, and you can talk to each other. But you want these like small discussions, and like since you can't have parallel discussions online, depending which tools you use, but that is more tricky. So you could do it if you're just a small project team or a group that want to try this out. I think it's quite fine, but in a larger setting, absolutely, you should wait and follow the recommendations by Folkhälsomyndigheten.
Yes, thanks. We have a question from Lorenzo as well. Is event storming mainly used as a mean for business process modeling and or requirements engineering, or what would you say the number one goal of event storming is?
Yeah, that's also a good question. I think like if you're going to describe it to someone who hasn't used it before, I think like requirements engineering and process modeling is like the two more generic terms that will like make you understand it in general a bit more. But it's actually kind of flexible, and I think the strongest like use cases you usually start out with that. So you start out with, okay, we're going to build a new system, we want to find out the process for it or the requirements. So that's how we start. But like if you compare it to just an interview or requirement document where you have like classic user stories, okay, you can use that as a basis, but here you can actually iterate on the same model. So the model you create at the start is also something that you can continue to work with and refine like during the whole implementation. And also, since you use the building blocks of domain-driven design, you have aggregates, you have events, commands. If you go into a bit deeper, I didn't go. You saw the slide in the end where I have all the notations. But when you use like those notations as well, it's more or less like the different like it's of course a higher abstraction than if you have like your code, but it's still a quite detailed abstraction, so you can actually do your like software architecture based on that. Of course not from the first session, but you can iterate on that and take it from the first session with the development team and then put your software model and basically take it all the way down. So I think I had a slide also with like a note pad or something that said big picture, process modeling, and software design. So that's the three different levels where big picture is only events and you do it with the business. Process modeling is a smaller group, maybe with some business experts, and then software design is usually only the development team. But you can like use the artifacts from the start and then drill down into more detail.
Yes. Thanks. And we have questions keep coming in. Very nice. And before I can prepare another question, but I know that Daniel, you said something here when we
Yes, I'm
spoke.
wondering, do you have any input on how do you convince the organization to start working like this? And I mean, how fast can you see the result of that, the value, so to speak, of that work?
Yeah, so we knew like when we were going to start out that, okay, we're going to build a system using domain-driven design, and also we wanted like events or messaging as be like a key architectural principle that we're going to use. So we looked for like ways of gathering requirements that would help us like in that manner, and then we found event storming, so that was one of the points. But what we did was, okay, we had buy-in to do this project, and then we just said this is how we're going to do it, invited people, and usually I would say that, I mean, you need the business input to know what you're going to build, and in general, as a business representative, you want to impact the way your future system will be. So if you can just be of any assistant, I mean, you will be that, and this is a good format since you can actually help, not only at the beginning, but you will establish this common ground, which is good. And then, like, if I think that a lot of people have found, okay, this is actually something that I can contribute in a meaningful way, and then it's also like the collaboration further in the project will be better, because you will have met each other, you would have like this common ground to talk about, and the notations, and it's kind of helpful. And you don't like need a board decision to do this. I think you should just like go ahead and do it. Of course, you will need to get the different resources, like the important people from each business line. But I mean, I hope that you would do some form of requirement analysis in each project, and you can do it in this way instead. So you shouldn't think too much about it, I would say, and just go ahead and do it with the persons available. But of course, if you can sell it like as a new start, or I think, yeah, you can find some way to do it. And for us, it worked just good.
Nice. I think we go for one more questions here, and then we need to continue.
Sure, I can answer
station.
the other one in the comment fields maybe.
Isaac is wondering, how do you document and capture all the events in an effective way once you have completed the event storming?
That's also a good question. You will get like this large canvas. So what we did first was like we just took it down and we moved it a bit, because we had it in the cafeteria, or so it couldn't be there, but we put it on another wall because it was kind of nice to just have it there and we could reference it back to it. But then we actually digitalized it. So we used this tool called Miro, where we basically just photographed it, and then it took us maybe 1 or 2 hours, so not that long time, to just do a digital sticky note and just type in what it said. And I mean, we haven't really used that, to be honest, but it's good, like, you know, you got it if you want to refer back to it. But I think the most useful is the conversations that you have there, and the findings. I mean, they will be so apparent that you will remember them. Not like the exercise itself is the most valuable part, I would say.
And you know this canvas by heart now after you put it into Miro?
Yeah, more or less, no. But I mean, as a new person, if you're a consultant or new to the business, or maybe new to this part of the business, it's actually kind of good, because you can just walk from the start to the end and just read it. And it's basically a story just telling itself about how the business works. So that's very good for a lot of people. So a lot of, we had a lot of new people when we started the project, and everyone thought, okay, this is my go-to place for just referring like how the business works. And that's maybe good as well, just to keep somewhere if you have the physical space to put it up.
Yes. Thanks. And now it's time for our second session of tonight. And so I would just hand over the word to Mikael, Philip, and Christian, who will talk about moving analytics to the cloud.
welcome to moving analytics to the cloud. We're going to have a short introduction about this topic, and then I'm going to introduce a couple of other persons. So welcome very much to this topic, and hope it's going to be good. We're going to be 3 different persons who are going to talk today about this. It's going to be me, Michael Forsberg. I'm a senior cloud advisor. I've been working quite a lot with Google Cloud and other cloud platforms as well. And then we're going to have Philip, who's going to introduce and talk a little bit about customer cases. And we're going to have Christian, who's also going to give you lots of good things about moving the analytics to the cloud. So, moving analytics foundation into the cloud. What it's all about, and why are you looking into this? We have seen that lots of our customer is today looking to moving from on-prem solutions more and more into the cloud. So it's going to be something that's going to take up to speed quite fast. But it's quite important to understand that we are in the early stages here. Mostly of all things that are done today in the IT is done on-prem, and there is not so much of it that's done on the cloud. But the speed is taking up quite a lot. But it's in early stages and it's going really, really good. So I think it's something to look into. What you need to have in mind also is that traditional data warehouse solutions and data solutions are still, the foundation is still on traditional solutions, like on-prem and so on. But moving into the more modern solutions like you can use in the cloud is something that's going to get your speed and going to get more innovation from it. And what we see from our customers is the first steps to do this is always looking into some specific data pattern or data sets or analytics specifics that you would like to dig into and look more into the new analytics environment. So we see typically customers who won't like to test these kind of things, and the data and the data warehouse modernization, I think, is the first thing to do. What you see there is they break down silos, and it's increasing the speed of innovation, and you get lots of things from the platforms that you didn't get from only having the data stored in silos or on-prem solution. And what also the cloud providers are telling us is that they see that their implementation in the cloud is also giving you lots of things that you couldn't have when you have it on-prem. And it's breaking down silos, utilize faster network speeds, and enable more powerful analysis. And all of this to lower cost. And I think what we have seen is you're getting much more speed also. So you don't need to take care of all the tech things, or you can do it in a small laboratory way of doing things and verify if it's work. And if it doesn't work, you can throw it away. What I would send to this as a recommendation is when you're moving your analytics to the cloud, it's thinking about how you deliver this cloud journey and what promises you send. Because we have seen lots of examples when you're maybe sending more promises than you can keep. So try to keep it a little bit shorter and be very specific what you're gaining for, what you're trying to achieve to both to your customers and both to your internal persons. Now what would I like to end with is starting from the right perspective. And when we come to that, it's like naturally you would like to deliver business value. That's what everybody would like to do. So you need to have a clear view of how you deliver your business value. But what we have seen is that many start from a technology perspective, and they're trying to convince persons or companies that what technology to use to achieve this business value. But what's really important is that you also understand what strategy you would like to accomplish and what business model and what you would like to solution you would like to do. So when you combine these 3 things together and coming together from the right perspective is to describe what technology that enables the strategic initiatives is the main thing. So you can gain the business value from that. And I think it's time to let Philip and Christian to talk a little about how you use Google and Bigquery to modernize your data warehouse and get the real-time business insights.
Thanks, Michael. One thing to keep in mind when working in GCP or similar cloud environments is that it's a new thing that got potential. It's not simply a tool that can replicate your current solutions and put them to the cloud, but rather a way to enhance these solutions in a manner that fits your needs. For example, let's say you have many different Excel sheets circulating around this organization, a situation I'm sure many of you can relate to. One way to utilize cloud is to simply automate this circulation by ingesting the data, calculating measurements, and distributing Excel documents to the recipients. But this may not be the best solution. Maybe you want to visualize some of your measurements in other ways than just numbers and tables in static sheets. Maybe you want something interactive. Instead of having 5 different sheets in one document showing the same things for different departments, you want one report that filters by departments instead. And maybe you want to do some analysis on the data and visualize that as well. Or maybe you want to integrate data from other sources into the reports as well to create new measures. You can obviously go on and on here. This brings us to a new kind of way to work with data. Let's say you have this solution. We don't need to get into all details here, but let's say you have identified a way to distribute data from 2 sources out to some users via a company-wide data warehouse. As time passes by, maybe you identify another use case and want to distribute data to another group of users. Starting from the right here, you can look into your data warehouse to see if you already have the data you need. If you do, you can take what you need and do the calculations and transformations you need and then distribute the data. If you don't, you need to figure out what data you need and how you can integrate that new data. Let's say you need to integrate yet another data source. As you can see to the left, there are different ways to do that, and you need to identify a way to ingest the new data that works for that data source. Maybe this can even open up a new way of working with the data source as well. When the ingestion is done, you can integrate the data into the data warehouse. By doing this, you make things easier for the people developing the next use case, just as the approach from use case 1 helped the developers for use case 2. Another thing we have learned when working in the cloud is that it's an iterative process. Last week, when Christian and I discussed this, we drew parallels to the smartphone. We all know that the apps get updated once in a while. Most often, the updates are very small. What I'm trying to say is that any given application on your phone never really gets finished. There's always things to improve and functionality to add. It's basically the same thing with your solutions in the cloud. Rather than thinking like it's an actual smartphone, where, for example, iPhone 11 has a clear release date, and when it's done, it's done. Cloud solutions are a work in progress. If we look back at the example from the previous slide, when a use case is first presented to selected users, it's more like a beta version of a smartphone application, not the finished product of the smartphone itself. We think this is a powerful mindset to have in the organization when working in the cloud environment. This is also where you can enhance your current solutions, as I mentioned earlier. Working in this way, you can involve the users in the development to catch their ideas of improvement. Some of them may not like working in Excel at all. This brings us to our next topic. To be able to succeed in the cloud, you need to synchronize your stakeholders. This picture you have seen before, and now I have added circles which represent the different stakeholders from a recent project. Each of the 2 data sources has their own expert. Then we have my colleague Christian, who did the ingest parts of the project, and then me, who built the data warehouse and data marts in Bigquery. And then we had the representative of the users. So this project is in an early stage with only 5 stakeholders. But as the system gets bigger, you get more stakeholders, and some of them will, of course, change along the way. Either way, it's important for all stakeholders in this example to be aware of changes happening that can impact the whole solution. For example, if something is changed in data source 1, whether it's a new field in the data or a complete overhaul of the structure, the others need to know about it and adjust. The people working with this data source may be used to work in a certain way, and you may have to make adjustments, for better or for worse, for it to work with a new cloud integration. There are things you can do to maintain control of the system and handle changes in input data. Christian will talk more about that later in one of the quick tips. There can also be a change in the organization from the user side to the right in the picture that we need to know about. In this example, we have a permission structure among the users, and if that structure is changed in any way, we need to know about it and adjust that structure to make it work. Another thing to keep in mind when working in cloud is that there's many different ways to construct your system. The example we have shown is just one part. As you can see there, the data sources are ingested in different ways. There could be multiple reasons for that. You obviously need to take into account how the source data is structured and how you can ingest that data in a manner that works best for you. There isn't a one solution fits all here, even though there are guidelines and best practices. And as the cloud environment is still quite new, these best practices change continuously. So it's important to keep up with the new technology that your platform is providing. Also bear in mind that this applies to both solving smaller problems, as how to ingest data from an external data source, as well as how to best construct the whole cloud system. And that wraps up this part. So now it's time for the 15 quick tips. The first tip is to use project fragmentation. Projects are a very useful way to contain coherent components. In this example, an expert on data source 1 can work in a separate project without disturbing other parts of the system. Data source 2 may need entirely different components to ingest, so there isn't really any reason to hold them together in the same project. It can also help in maintaining a clear overall structure. Using project fragmentation, users and user groups can be involved in only those projects they need to be involved in. For example, one user can be a project owner in use case 1, while having read-only permissions in the company data warehouse project. It is also useful when debugging. If something goes wrong, you can get a handle of it faster if you can limit the number of possible sources of the error. Number 2, Google Cloud and cloud in general provides you with different ways to solve problems, as we mentioned earlier. You can utilize this to create flexible development solutions. If you maintain a module-based structure from the beginning, you can create development environments based on the need in question. For larger features, it may be best to keep a dev version of an entire project, while for minor features, it can be enough with a smaller component. For example, if you want to optimize a view in production in Bigquery, you can keep a dataset as a sandbox environment, where you can work on your view with production data without disturbing the other views in production. You can basically create small dev environments when you need them, and then delete them when you're done.
Next up, we have the heart of the data warehouse solution in GCP, and that is Bigquery. And that is not your traditional database, even though it has the tables, the views, and the standard SQL syntax. It's really optimized for handling a huge amount of data and then doing queries against that. It's a fully managed system from Google, and it scales to multiple petabytes. But the key thing is that Bigquery doesn't slow down when you add more data. And this is because it takes your SQL query and converts it into a job that it can then distribute over the Google infrastructure on many nodes. And then it can collect all the results into a new table. And that gives you a consistent performance without the need for traditional indexes. A common way to do ETL in GCP, to get the data into Bigquery, is by using a service called Dataflow. And Dataflow is a fully managed batch and streaming data pipeline from Google. And it offers horizontal scalability, and it can run jobs that is created with the open source Apache Beam SDK. And you can use ready-made templates, or you can write your own using Python or Java. And Dataflow is perfect for doing ETL, like both the your batch jobs that you would traditionally do with Hadoop, or with real-time streaming jobs. So you really have one tool for all your different kinds of ETL jobs. And another use case for Dataflow is for machine learning. Another great building block that can be used together with the Dataflow is something called the Apache Airflow. And it allows you to create pipelines and orchestrating different tasks. It allows you to, for example, look for a new file, and when this new file appears in a storage bucket or gets updated, it can spin up a Dataflow job to transform and load that file into Bigquery. And Google offers a fully managed implementation of Airflow in GCP, and it's called Cloud Composer. And this is because Airflow can be a bit tricky to set up. There's a lot of moving parts, and a Cloud Composer will take care of that for you. It will give you a Kubernetes cluster with Airflow installed. It will set up a required SQL database and a web interface to administrate it. It will also integrate with the Google Stack driver to give you logging and monitoring in the same way as all the different GCP services.
Yes. Number 6, when you have data in Bigquery, there's multiple ways to interact with the data. You can use Google's own tool, Data Studio, to quickly get going with analyzing your data. It is also possible to connect the data to third-party software like Power BI or Tableau, or to further explore the data. If your company already uses any of these tools, it makes it easier for the users to adapt. These integrations make it possible to create reports and distribute them at a large scale throughout the organization. Here it is important to keep in mind the organizational structure and define users and groups in a way to obtain a solid permission structure.
So what does it cost to run the data warehouse in GCP? One concern that we noticed with several projects is about, there's one thing to move the data into the cloud, but what does it cost and what drives the cost? Because in GCP, the cost structure is not what you would typically find in your traditional system, like with Oracle, for example. So there is no license for running it. So it's entirely based on, resource usage. The storage in Bigquery specifically is very cheap, and you even get the first 10 gigabytes for free. But a thing to note is that you pay for all data being processed. So if your query returns one row, you still need to pay for all the data it had to go through to find that row. But here as well, you get a bit for free. So you get 1 terabyte of processing per month, and then you pay as you go. But even though the cost might be low, there's still ways to optimize it, and I will talk about that a bit further. But from our experiences, it's not really the data warehouse itself that has the biggest cost. It's with the ETL pipelines. So if you have streaming pipelines running all the time, like processing data to put into your data warehouse, that's usually where the cost is. To really support an iterative development, you should use something called infrastructure as code. So that means that instead of creating everything manually in the UI, clicking and modifying things, even though it's super tempting, and then try to document it and keep that up to date, you should use a tool that allows you to define all the resources and infrastructure in a code, and that way you get the documentation for free. And it's always up to date, and you get a reproducible environment. So you can quickly throw up a duplicate environment for testing, for example. And a really great tool for this is Terraform. It's from a company called HashiCorp. We use that in a few projects, and it's been super helpful. And it works great with all the different components in GCP, and it even comes pre-installed in the Google Cloud Shell. Yes. So now, when you have your environment provisioned and so on, you have to think about, security and how to isolate it. And one way to do that is to put the resources and the different tables or parts of your data warehouse in different projects and set permissions that way. Philip touched on that a bit previously. But in most cases, you want to have, even finer granularity. And that's where the datasets come in. So dataset is a collection of tables and views, and you can set policies on who can do what with those tables and views in that dataset. And Google actually launched column-level security in beta just a few weeks ago. And that also allows you to set the policies on specific columns in tables. It's also possible to get row-level security, but that is a bit more complicated, but it is possible. And a general best practice in GCP is to use the principle of least privilege. So you would only get permissions that is, just enough to do the job required. And you should always, give the permissions on a group level, so not to individual users. So that way, it's much more manageable, and you will have a lot less headache in the long run. I promise you. So now, when we have, possibility to provision and to set the permissions, we also need to think about, how to make the data warehouse resilient. Because there will always be things that stop working, APIs become unresponsive, your source systems might change, the schema might change, there will be things that change. So you should really allow for failure. And one way to do that is also to allow for duplicates. So you can, rerun a failed job with confidence, because, rerunning the job, you have the risk of having duplicates. So you should really, allow for that. And one way to do that is to use views in front of your ingestion tables to just filter out, those duplicates. And this is especially important when doing infrastructure as a code, because you want to have a reproducible environment. And you want to, have it working all the time. And another thing to think about, when doing that, is to exactly specify the versions of different dependencies. So in your Airflow jobs or data flow jobs, you should specify exactly what kind of versions you want, so that when you rerun it, 6 months from now, you know that the combination of dependencies will work in your setup. We had a few cases that we noticed that things stopped working, and that was because a new version of a dependency behaved a bit differently than previously. And as mentioned before, Bigquery is not your typical database, and the queries pretty much run across the entire table. And even though it's distributed, there is still, a slight performance impact, but mostly it's a cost impact, because you, of course, pay for all the data that is being processed. So one way to mitigate that a bit is by using partitioning. So partitioning is, as it sort of implies, is that you would partition the table into sort of hidden tables. So one way to do that is to do it by date, for example. It can be create date, modify date, ingest date, or you can use other things as well. So in the background, Google will place that data into like different hidden tables. So when you do a query, it can figure out like which sort of subsets of the data that needs to be processed, and you only pay for that. And there's also, the performance impact on that as well. There's less data that needs to be collected and orchestrated. And a sort of a additional thing you can use with partitioning is clustering. So clustering is kind of a sorting. So data that is relevant gets placed together, so it's quicker for Google to, process that and find that. So if you have queries with filters where you have like, let's say you have a business unit, so like that would really allow you to speed things up.
Yes, a powerful feature in Bigquery is scheduled queries. They are useful when you have complex joins in your views and need to materialize your data into tables. In this example, we have a table that is updated once every 24 hours. As Bigquery isn't a traditional relational database, the best uses for these queries are to truncate or append to tables. One nice feature for these queries are the synchronized schedule. As you can see under the schedule, it says every 24 hours synchronized. Synchronized in this example means that the query will run at midnight Swedish time. In the same way, every 2 hours means that it will start at midnight and then run again every 2 hours. This makes it easy to keep track of when the data was last updated. Scheduled queries can be created in the graphical user interface as well as provisioned using Terraform. One interesting feature is to use Google Sheets as data source in, for example, Bigquery. In a recent project, we figured we needed a better way to input data manually to the system. So we created Google Sheets documents for this purpose and connected them to Bigquery. This makes it easy for someone without the GCP expertise to insert data into the system. It is pretty straightforward, and you can do it right in the graphical user interface as well as provision it using Terraform. Google Sheets is an application outside of GCP, so here it's important to keep a permission structure in mind that works. Permission can be controlled in different ways, for example using AD groups. Another neat way to input data into GCP and Bigquery is using Google Forms. This enables even more people to input the data to the system. Forms can be used externally as well as internally to collect information from a large number of people. The results can be stored in Google Sheets, which can be connected to Bigquery as I described earlier. We have used these as a commenting function in a project recently. There we have a distributed Data Studio document, which includes user input comments that are connected to the data. As these comments can come from multiple people, we decided to use forms instead of using sheets directly, as this can get quite messy if many people write directly in the document. As some of the values are connected to filters in the report, we need to control that these values we get have the right format. It is important to keep in mind when using forms, to formulate the questions and to utilize the functions there to get the format you want.
So, last point. And now when you start to ingest a lot of different data into your data warehouse, you might have data from CRM systems or from marketing systems. There could be a concern about privacy, especially in the EU with the GDPR, because you will start ending up having sensitive information in your data warehouse. But Google has a really cool tool that can help you with that. It's called the Data Loss Prevention Service, or DLP for short. So it can use different filters and methods to detect sensitive information. So it can be like personal numbers, it can be phone numbers, it can be age, it can be occupation, and so on. So the DLP allows you to sort of tokenize it, mask it, or like reduce the accuracy of it. So if you have a job title, you might have chief engineer. It can change that to engineer, which is a bit more general. And you can also use this together with Google Key Management Service. So you can encrypt different rows, and you can encrypt the sensitive data using encryption keys. And if a user wants to be forgotten, you can sort of delete the encryption key, and that way you can't retrieve the sensitive data anymore, but the data that wasn't sensitive for that user can be retrieved. So that's like a really simple way to be able to comply with regulations and or help you to comply with regulations. And to simplify things. So that was the last point, and I hope some of it has been useful, and thanks a lot for me.
Welcome back, and thanks for that presentation, Mikke, Philip, and Christian. We have received two questions here, and we start with a question from Manuel. Philip, could you give a good use case where you would pick data flow over Composer?
Where I would pick data flow over Composer. A good use case, you could use them in combination, but a good use case for only using data flow would be to use for a smaller use case, as Airflow could be or Composer could be quite an expensive solution. But
is it expensive depending on how much data you use, or why is it more expensive?
It's kind of a orchestration tool. Like if you have a small solution, you don't really need to have that kind of orchestration. That's basically what I would say.
Okay. So for so the conclusion is, for more complex solution, you would use Composer, and then for more, lightweight use case, you could go with Dataflow. Is that it?
I would say that.
Yes. Great. And have a question. I don't know if you have the answer for this one or it's Christian, but Lorenzo asks, how do you limit the scope for a project in GCP? And are there cases where one project support multiple use cases?
The limitations for the projects is basically up to the user. You could choose yourself how you want to delimit things in projects. You could have everything in your solution in one large project if you want, or you could separate in different projects based on different kinds of parameters. We have in my talk here, we proposed one way to do it. You could do it in several other ways that may be better or worse depending on your solution. But there are some guidelines and best practices to do that.
Yes, and I know that you had a question as well,
I was
August.
just thinking a bit about like when should you not use GCP or the cloud in general? When it's maybe better to have it on-prem? Are there any like trade-offs or situations where you would prefer the one over the other?
Good question. Many people may be a bit wary to use sensitive data in the cloud, but we actually have a bank customer who recently signed off to upload their data to the cloud, and Google has quite a few solutions for security and stuff like that, as Christian knows a lot about. So there are solutions for that. And one other case where I should say you should not use cloud if you have an on-prem solution that works very well and you don't really have any reason besides it's good to go to the cloud. If you don't have any explicit reason or better to embed your solution, then you stick with what you have if it works, unless you have a explicit reason.
That sounds reasonable.
Could this also depend on how mature your IT organization is? If you have on one side monolithic and people working all by themselves, and on the other hand you have cloud native architecture and applications that was born in the cloud. My question is, do you need to have where on this scale do you need to what levels do you need to pass to be able to get the powerful strength from the cloud?
Good question. I would view it like this: if obviously you need to have the organization with you when you're doing this. You don't just start cloud here and expect everyone to just adapt. You need to figure out how ready the organization is for the cloud and things like that. I would say, it depends on your organization how ready you are.
Yes.
If you don't feel you're ready, then you should probably look into that.
Yes. Would you like to add something, Daniel, or should we continue with session number 3? Yeah, I think we go with Per, who will talk about Medmera Bank's journey to become an event-sourced bank. So over to Per.
Hello, and welcome to this presentation called the Event-Sourced Bank. My name is Per Eriksson, and I work as a solution architect at Forefront. So, about me, I've been working in the finance sector since at least about 15 years from now. I have a big interest in event-based solution, which is what we're going to talk about today. So, to start with, what is event sourcing? Well, according to me, I see it as a design philosophy to model the domain as a series of events instead of focusing on the current state. Okay, so what is this then? Well, to explain, let's imagine an account application holding information about people's accounts. And how would we build that if we focus on the current state modeling? Well, this is like more the traditional way of representing or modeling your domain. We use a database table. So we have a database table with the accounts. And what happens then? Well, we have a new account. I create an account in this system. Then, of course, we create this row with balance 0. And what then happens is that I make deposits. So I deposit 100 euro, and we update the balance to 100. I deposit 200 euro, and we update the balance to 300. And then perhaps I make a withdrawal of 160 euro, and we just update the balance to 140. We always represent the current state of this balance in this account. Okay, so how would this look using events and event sourcing then, using the same scenario? Well, we don't model the new account by creating a row in a database. We implement the event itself. And as transactions happens, we capture the interesting information from them in other events. And there are no traditional database here. We persist the events themselves. So here we have modeled each event as different event types with some information in them. An important thing to note here is that we can always derive the current balance information by just looking at the series of events and making some calculation from them. But we cannot derive the series of events by looking at the current balance in the previous example. So for this example, the previous one, there's no way for us to know how we ended up with 140 here. So there's actually a huge difference in how we solve this, how we implement this, what kind of things we can do. So why are events interesting then? Well, because it's often a better way to work with data, as I see it. And just as we saw in the previous example here, if we work with only the current state and compare that to working with a series of events, we actually have, looking at the total information content, we actually have more information when we work with events. We can say that working like current state always is a subset of the amount of data that we have when we work with the series of events. And also, what else? Well, when we build our systems with current state modeling, we must focus on how the business look, which is pretty much a static way of thinking. And when we build our systems based on events, we focus actually on what happens in the business. It's more like a dynamic way of working. And I would say that the dynamic flows and the events that happens in a business is often more interesting to work with, and it's often there where we can have value in our solutions. And also nowadays, when we build microservice architectures, where each application handles some small part of the domain, applications need to communicate much more often with each other than before. So, for instance, this blue application here that handles customers, we say, all the other applications in our systems need to, of course, go to this application and ask to get some customers, get customer 1, 2, 3, for instance. And this will result in a particular customer to be transmitted to other applications many, many times, because each time application asks, get me customer 1, 2, 3, we have to respond with that customer. Whereas in an event-based solution, this orange one, we only need to transmit this customer one time, and that is when the customer is getting updated. And then the other applications can consume that event and stores its own view of that customer, so to speak. They don't have to go to ask each time. So these are some of the arguments why I think events have a perfect fit in most modern architectures. So going back, why are events interesting? Well, I think that the future will be about delivering contextual and personalized real-time services to our customers. And we have to have an architecture that can support this, of course. We have to have an architecture that can record and handle as much data as possible about the customer. It has to work in real time without batch dependencies so that we can deliver these services on time when the customers demands them. And we have to focus on the dynamic flows and what actually happens, and not be static looking at data that are just static. So going back to Memera, where I have been working the last 10 years, Memera is a consumer bank that has 3 main products. They are debit credit cards, consumer loans, and savings account. And this is just a timeline of the previous 10 years. 10 years ago, there were just a couple of monoliths, some COBOL based. Then after some years, we started working with web services and introduced this huge ESB that sat in the middle between our backend systems and our customers. That also became kind of a monolith. 2014, we started working with microservice pattern-ish, since it was just a few of them. And then at 2016, we started working with events more seriously, which led to event sourcing. And now I would say we are it's some kind of streaming data architecture, at least partly. But what is interesting here is that we have moved from a closed and complex architecture where each change required a lot of time for development and first and foremost testing to make sure that we didn't break anything that we had missed, to a more today open and clearly defined architecture. Now we can have changes implemented in production in hours, which would take days or perhaps weeks previously. So how did we start this journey with events back in 2016? Well, actually, it started with we had to build a new CRM system to handle customers and handle customer information. So this was a pretty central system in our bank, of course, for doing name checks and fetching customers and addresses and that kind of stuff. We built this using CQRS patterns. So each command or change was also actually emitted to a Kafka topic. And this Kafka topic we configured with infinite retention time. So we were never supposed to delete anything from that. We were about to store all the changes to all the customers forever, basically. And those of you who have worked with Kafka know that you can configure on a topic level the amount of time that you want to save all the data on the topic. And normally it's pretty short, perhaps a week or something. But here we had infinite. And we defined for this system, we defined a write as when we have persisted the change into this internal MongoDB that it's also had and emitted the change as an event, then we have completed the write, so to speak. Okay, but who was the consumer of these events then? Well, actually no one. We had other applications like public websites, internal admin applications and so on, but they all used the REST API. The events didn't have any consumers. So one might ask, why did we even do this? Well, because we thought that there will be a need for this kind of information in the future. And after a couple of years, AML came to the rescue. AML stands for anti-money laundering, and it's also one of these things that banks need to be concerned with. And AML definitely concerns customers, so this information was very relevant. And when we started working with this, we saw that we needed this data. So we built an app that subscribed to this event flow. And actually looked at whenever new customers, these new customers events appeared, and then it got exported to some external monitoring systems for monitoring AML. We also built another systems for more an event source system that tracked customers' KYC questions to figure out when customers need to update their KYC answers. And KYC is things like that we ask the customer, from where do your deposits come from? So that kind of stuff. We also replaced old file batches with Kafka Connect to export customer information in real time to our BI systems. So we were a lot more happy now that we could get use of this data that we built a couple of years back, of course. Some current work in progress. Well, we are actually looking at having this CRM system to event source itself as part of a migration project. When we build new microservices, we often make them event producers or consumers in some way, because they often have that kind of information that can be useful for other. And as we see that our data that we have in our event platform grow, we can also make use of different tools for doing business insight to make more information from this data, derive more information. And we use Kafka Streams and KSQL, for instance, for doing this. So we see this that we have like built ourselves a streaming data platform where we can have ready to consume data and offer this as a capability to the business and to other projects, so to speak. So we will move on to present these 6 key success factors that we have identified during these years working with events. Number 1, reusability. I mean, one purpose of putting time on architecture at all is to build things reusable so that we can use them for other things that they were originally thought of. But building things reusable also costs very much in time and effort to just figure things out, how to make it reusable, because we have to envision the future. So should we even try to do things reusable? But I think that in terms of designing events, that's one of the things, the parts of the work that you could put some effort into. And I think the key here is to try to design your events so that they are business or domain focused. So you need to involve the business side of things when designing, trying to figure out what events are important for the business, what defines the business, and what information or metadata should be put into these events so that it is relevant. And I would recommend using DDD, domain-driven design, or that kind of methodology to when we're working with this. And also, I would say it's important to use schemas and tools for handling how the events actually look. So there are, for Kafka, for instance, there are schema registry where you can put all your schema that defines how the events actually look, and so on. So the key thing here is that when we use a business-focused design, we not only make the information model more transparent and understandable, but I also think that it will get more reusable going forward. So number 2, so given what we have, how do we move to an event-based platform? Well, to start off, I wouldn't say it is a move or a replacement for all your REST services. It's a complement. I mean, if we look at going back a few years to SOA and ESB era, then we had to make this huge decision to move all integration into a central hub for transformation, control, and governance, and that kind of stuff. We had to make this as a huge investment and also a huge risk to take that step. And I don't see this as the same case. We can only have one topic, one event stream that still has very much value, and that might be everything, all that you build, so to speak. So start small and perhaps start on some hosted event platform on GCP or something, just to not having to put that much effort into the infrastructure parts. And then perhaps start working with the schema management, and then after a while start streamlining your configuration and routines and that kind of stuff. And then after a while start working with principles and conventions and all those stuff. But I think the key takeaway here is try to just get something out running so that you can start learning from how this works and where you need to place your thoughts in the future. Don't try to solve all the aspects up front in the beginning before you have even started. Number 3 here. I mean, one key aspect of building robust architecture is to strive for loose coupling. And this is even more important in the microservice era that we are in right now. So looking at this example, for instance, where we have a lot of small microservice applications that basically, for some reason, all depend on one application in the bottom here. So what happens if, for instance, this application in the bottom crashes for some reason? Well, then our whole platform will crash because they all have dependencies on this application. So how do we solve this in the traditional microservice pattern way? Well, of course, we probably have some kind of redundancy on that application. So we have perhaps 2 instances of it. And if one dies, then we have a load balancer that can just balance all the traffic to that one. Or we can perhaps have caches in these other applications that caches data, or we have circuit breakers or that kind of patterns. But all of these are like more components and more solutions that you have to put into your platform to make it work, to start to have loose coupling. And an important aspect of event platforms is that this decoupling aspect basically comes for free. And you can say that you have loose coupling in both space and time. And with space, we mean that a sender don't need to know where the receiver lives and vice versa. I mean, for a REST service, you have to, a sender need to point out that I want to communicate with this service. And with time, we mean that the receiver don't need to be alive at the time the sender produces a message, and vice versa. I mean, as we saw in our example, when we built our CRM system, the receivers of those events wasn't even built at the time that the messages were produced. So if we look at the other scenario built on an event platform, if this application, if one application dies, it doesn't even mean that the other application take notice of that one. So these are very decoupled in that sense. So this is a fact that we can use when we design for robustness in our platforms. But of course, this comes with a price, and that price is asynchronicity. And this can be a problem that we need to handle. We can have timing issues when it comes to data consistency and so on. And this is something that we, of course, also had some problems with and had to figure out how to do. And this leads us to the next key factor is how to handle asynchronicity. Well, imagine this, for instance. We have a client here making a synchronous REST call to some application app1 here, which in turn triggers an event that application 2 listens on. And at the same time, the client make a second REST call to application 2. So how do we guarantee here that the effect of the event has actually taken place before the second REST call is handled by application 2? This might be important for that event to actually be handled before it can serve the REST call. Well, I mean, this is a fundamental issue in distributed system. There basically doesn't exist any silver bullet solutions, and it is of course related to eventual consistent DBs and XA transactions, that kind of things. I mean, some naive solutions here might be that application 2 waits like 5 seconds before responding to the second REST call to increase the chance of it getting to consume that event during that time. And this, we also had some parts in our solutions where we actually built like that. But I mean, it doesn't feel really good, that kind of solutions. I would say that the best way to handle this is to avoid having like synchronous flows depending on asynchronous flows. So basically, once you go to an asynchronous flow, you have to continue to be asynchronous. We try to invert the initiator and push data instead of pulling. So if we go back to our scenario here, it might be that, you know, whenever app 2 has consumed this first event, then it does whatever effects that application 2 is responsible of, and then it pushes another event to the client instead of the client pushing or initiating a request to application 2. So number 5 then, always remember Murphy's Law. I mean, what can go wrong will eventually go wrong. We can have lost messages, we can have duplicate messages, buggy consumers, junk data in events, and that kind of stuff. I think it's important here to make our consumers to behave forgiving. We can apply the robustness principle, which basically say, be conservative in what you send and be liberal in what you accept. So for instance, junk data can just be logged and then ignored or moved to some dead letter queue, and that kind of error handling strategies. It's also extremely important to have our consumers idempotent so that they can handle duplicates, messages that had already processed in a way without side effects. So basically we say that consuming some event one time or 1,000,000 times results in the exact same outcome. And that is very important for having a robust solution. Also, we should design for redos, so that perhaps in some time we want to rewind our consumers to start consuming old messages again from a previous point. For instance, if in an events sourcing application where we have some kind of bugs in our consuming side, so that we want to rebuild the state with some kind of other logic, so to speak. This is also something that we have done in our work. Yes, the last key success factor, GDPR, is of course something that we all have had to work with, probably. In our case, we had this topic with consumer data that we designed was never going to be removed from at 2016. And then at 2018, where we had to solve GDPR, it said that you must remove your customer data whenever the customer is not longer a customer. Okay, so how do we do that then? Well, I mean, those of you who know Kafka, knows that Kafka doesn't really offer anything like, delete from a topic all the events concerning this customer with this personal ID. So what is the solution here? Well, of course, the most naive way is just to have very low retention times, to throw everything away after a week. But I mean, this makes future use of this data basically impossible. So if you want to keep the data like forever or for a very long time, we need to solve this in some other way. And for this in Kafka, we can have separate lookup tables, can also be Kafka based, and use this Kafka mechanisms of log compaction and sending tombstones to actually be able to selectively remove certain events from an internal topic. So to sum this up, what have we talked about? Well, we have explained why events and event sourcing are important tools in our architecture. We've seen how we can transform our architectures to be more event-based to make our business smarter, to have more data available for things, for analysis and things. And we've also seen how this can make our microservice architecture more clear and robust. And we looked at a number of different aspects that need to be handled during this transformation and some possible solution to challenges that might arise when working with this. So that was basically all for me. And I want to say thank you for listening and have a good day.
Yes, welcome back, and thanks for that presentation, Per. At this stage, we are missing our speaker, Per, here at the studio. So I will address you, Daniel, with the questions, because I know that you have worked together with Per at Medmera and have taken part in a lot of stages that Per was talking about. And here is a question from Björn, and now I see that Per has answered it, but for the AML solution, was there parts that only could be built using the full event dataset that would not be modeled by only a snapshot data view? I know that Björn, that Per talked about it during the point that said low stakes evolve over time, but I'm not really sure how I should what you meant. Could you?
I think those were two different things, but addressing the AML question, I'm not really into the specific details of each and every use case, more of the chosen technology and the platforms under it in this specific case, so I can't really answer the AML question. But I think the other thing that you referred to was the fact that how do you want to or how can you start this? Do you need to go big, or can you do it in a small fashion? And my reflection to that would be that you can do it very small if you want to, but the effects of it will be bigger and bigger the larger you span the things, so to say. So if you start small, you will see an effect, but you will only see an effect of those kind of business events that you are currently modeling. So it's not a problem to start small. It could be even a good thing to start small instead of starting with the whole thing and just driving into a wall and nothing gets done. So
yes, yeah, thanks. I hope that you got an answer there, Björn. And we have a question from another question that I address you again, Daniel. Do you have any comments and examples on business advantages that banks can enjoy from event streaming now or in the future?
I mean, the most usual use case that is brought up in these kind of things is obviously some kind of fraud. So by pushing events for things that are happening, you can monitor the user behavior and act on that accordingly. So you can, for example, turn off somebody's account or something like that if suspicious activity is going on. So that's the most obvious thing. But obviously there are other use cases as well. But mostly user-related, or it's easy to see the effect of those things, and it's easy to reason about because everybody understands how a user interacts with things. So it's yeah, I would say that.
Yes, thanks. Here is another question. How do you manage backups that are persistent, more critical, and infinity time? Do you get the question?
Yeah, I mean, in this setup we're using Kafka, and by nature we are partitioning data with replication, and we are most of the time we're using at least a replication factor of 3, so we have 3 copies of every piece of data. So, for example, if a disk crashes or something like that, that's not a problem. We can rebuild that in an easy way. But a harder thing would be if we get corrupt data into the system, because that isn't covered by that kind of thing. Then one way is to rewind everything to before that happened, and that could perhaps then you could perhaps say that all the events happening up to that state will be correct in some way, but you still need some way to handle those events after that, which could perhaps be done by having counter events, revoke whatever happened with the first event and so forth. But I mean, it is obviously possible to back up all of the Kafka data and reread that into a new cluster or something like that. But the point of that is, it's if you have a really major crash and both of your data centers burn down or something like that, maybe. But that's highly improbable.
Yeah, of course.
Yes, something I came to think about, but when you're in the bank context, I mean, when you work with asynchronous data flows, that's usually very good for scaling, but when you're in a bank context, there's a lot of transactions that needs to happen at the same time, like I move money to your bank account, that can't be like one event, and then, I mean, you need to make sure that that's one atomic transaction. How do you usually handle that?
And I would say that maybe that it is possible to handle that with sagas and so forth, but most of the time we probably handle that in a transactional context, and then the result of that might be an event that somebody can act on. But perhaps not that particular part is done event sourced. But I mean, it is possible to do, but it's a bit harder. It's not just.
So you choose the event source solution for where it's most suitable, not for everything.
Yeah, and it's, I mean, the most powerful way of using it is for real business events, not for solving the technical problem, but for solving the business events, so that you can notify other systems on business events, and they can act on that if they are interested, like addresses getting updated and whatnot. So so it's not. I think that's the place where it's most powerful, at least.
Sure. One other thing, if we have time.
Yeah, go ahead.
Like when you store everything, so in event sourcing there is, I mean, you have this infinite log. I mean, you only append to that, but if you have to remove sensitive data or GDPR classified personal data, how do you usually handle that?
Yeah, and that's also possible to do in there's a feature in Kafka called log compaction that actually looks at the message keys for all of the messages and removes. So you can, if you send in a new message with the same key but a null value, then it will remove all the prior messages. So it only keeps the latest record of everything. And then you have the problem, I think Per explained this in the talk as well, but you have the problem of correlating that to you need to know what kind of event keys have been used for this particular user or something like that. And for that you need to keep some kind of mapping table in that case. Unless the event key itself is something that you know by nature.
Yes, I'll describe this about, I think it was the GDPR, that was the example.
Right, I missed some parts of the talk, but thank you.
Yeah. And I think we have time for one more question. Daniela, how mature do an organization need to be? Do they have need to be started with microservices, or when should you?
Yeah, I think started with microservices, yes, perhaps, but I guess most are at least familiar with that concept. You don't need to have very much maturity to get going, but if you're going to host your own Kafka solution, that is not very easy. So you need a lot of work to be able to do that. So in that case, I would suggest going to a SaaS-based solution in the cloud instead. But it's totally possible as long as you have the wish to define the business events and have a need for them somewhere. Then it's easy. You don't need. You can do this from from a legacy system as well, just emit events, but somebody needs to be able to use them in the other end for it to be useful, obviously. So,
yes. Thanks for that, and we need to keep going with the next presentation, and next person is Rashid, that will talk about integration modernization, and techniques in focus are Kubernetes, Kafka, and Camel. So welcome up, Rashid.
Welcome everyone. Today we'll talk about integration modernization on Kubernetes, and which is a container-based, decentralized, and microservices-aligned lightweight architecture for integration solutions. My name is Rashid Amir, and I'm co-founder and CEO of Stagator. I am a container platform evangelist and a full-stack developer and architect. And I've been working with Kubernetes since 2015. At Stagator, we provide professional services around Kubernetes, and we help companies in their journey for Kubernetes adoption. So we help them in their strategies for Kubernetes containers, also with development and operations around Kubernetes. Stagator is a certified service provider and also a Red Hat Advanced partner. Stagator basically helps companies in their journey with containerization. As you can see in this offering stack of Stagator, we help companies in their whole journey, depending on whether they are a container newbie or they are a Kubernetes power user. And we help them on across different cloud platforms and also private clouds, and be it vanilla Kubernetes or any other enterprise distribution. And we help companies also with the trainings, with consultancy, and a lot of other time and material-based offerings. And then we also help companies in their platform reviews of Kubernetes or also with their enterprise container strategy. So what we're going to talk about today is basically how the integration world is changing and what is this new Agile integration architectural approach. And then we will look into the technical stack, the tech stack, and also we'll talk about some of the benefits of the Agile integration. And then we will look into a customer case as well, that where we have been helping a customer to migrate from monolithic-based integration architecture to more Agile integration-based architecture. So, as I mentioned, the integration world is changing, and if you look into the way things are happening now, that the organizations, they must tap into ever-growing set of applications, processes, and information sources across multiple clouds and also on-premise. And all of that actually significantly expand the enterprise's need for integration capabilities. And this need for integrations is now increasing even at a rapid pace. So like a lot of companies are adopting SaaS solutions to integrate with, a lot of IoT is going on, full-time processes automation, then we have this AI, and then also microservices-based application designs, which means the need for integrations is growing quite rapidly. So if you look into like how we have been doing in the integrations, was typically this, what you see in the diagram is more like we had a centralized integration, we had like centralized expertise, we used to have proprietary connectors. But now the whole idea is like you want to use more like containerizations, and these APIs, they're actually changing the whole thing. Now you don't have any more 100 apps. Now you have more like thousands of services, because apps have been broken down to smaller pieces, which are like microservices. And now the integrations can take place at any part of the organizations. You don't have to be like, okay, this is more like a centralized ESP architecture. Now this is going to be a decentralized kind of architecture. Integrations will happen everywhere, and it will connect all sort of applications. So then what do you need is more like an API-centric integration. And if you look on the left side of the diagram, it's more like a centralized ESP, which is more like where you have centralized function, ESP, you're running some old school centralized ESP solution, and then you're moving more towards what you say a decentralized but a more agile integration platform, where you want to use more APIs to connect with one system with another system, which definitely results in a lot more agility. You might have seen this diagram previously as well, but this talks about the different integration architectures and how they have moved from left to right, over the time period. So we have this, what we look into, what we call, initially we had this service-oriented architecture. So these black ones, they talk about the infrastructure concerns, and this more yellowish kind of thing is more orange, like the application concerns. So this was more like the architecture was like we had a centralized ESP, and this was like a very famous architecture way back in 2006 and upwards as well. We're talking about this service-oriented architecture. And then we are moving more towards what we call the microservices architecture, where things have been moving, like smart endpoints and dumb pipes. But now we are moving towards what we call more and more like cloud-native architecture, so that all the infrastructure concerns are taken away from the applications and they are offered as a part of the platform. And one such platform is Kubernetes. So where it takes care of all of your infrastructure concerns, like service mesh or whatever. All those kind of infrastructure concerns are taken care by the platform. So what is this new architectural approach, which is called Agile Integration? So Agile Integration is basically some modernization, how you do stuff, So traditional application integration was more like you had a centrally provisioned and administrator silo, that was what you call the ESP, and you're moving more towards like decentralized approach, So isolated integration deployment, application ownership, and more like cloud-ready implementation. And if you look here, like what are the three key pieces for an Agile integration, that results in, when you modernize integrations, results in the business agility. So there are three key areas, One is like architecture and design, then the people and processes, and then the infrastructure and technology. So Agile integration is not about only technology, it's like three different areas. So we're talking about the fine-grained deployment, which actually results in improved build independency and production velocity. So this is what you can call a deployment agility. Then it's like decentralized ownership, like people and processes. So this results in more, I would say, acceleration in agility and innovation. So what you achieve is a development agility. And then you're talking about the third piece, which is like cloud-native infrastructure. So it's like dynamic scalability and inherent resilience. So this results in operational agility. So basically, the Agile integration is a combination of the deployment agility, the development agility, and the operational agility. So you have to put all these three things together, and what you result in is what is called the business agility. So what is exactly the fine-grained deployment, So this is typically, I think, all of you might be doing some sort of microservices right now. So, and the microservices, what they result in agility, they result in scalability, and also in resilience, But just that microservices is just one of the architecture and design that influences changing the way we think about building components. So it's like API-led microservices, event source and cloud, and the list kind of continues. So that's like the whole idea, like having a monolithic kind of ESP is more towards, I would say, smaller, well-defined integrations, or like micro integrations, than what you could call. And then, like, talking about the decentralized ownership, so what is the idea of the decentralized ownership? So I think, as you might know, like typically how we do integrations is basically we have a central team that is running integrations. Then you have these, let's say, back-end developers and front-end developers, or anyone else. If you have to talk, you need to build up integrations, then you need to talk with the integration team. But the whole idea is to actually break that up, like make integration people like part of the development teams, or like a product or whatever kind of teams you have, so which basically results in increased team agility as a result of, greater autonomy and clear ownership. So the teams, they individually own the integrations rather than having a centralized team managing the integrations. And then, talking about the cloud native infrastructure, and what it is about, if you look on this diagram, how things have been moving from bare metal to virtual machines to containers to functions, So you're increasing the abstraction from the infrastructure. So, and the containerization is more than just a re-platforming exercise, Lift and shift will not bring the benefits. So it kind of requires a fine-grained deployment, organizational decentralization, pipeline automation, and also, disposable kind of components. It's an important thing. So which kind of results in, I would say, build agility, operational consistency, scalability and optimization, and also the team productivity. So this is basically, the three things that you have that can result in business agility. One very important thing that I would like to highlight here is that integration modernization will impact more than just your software. So you have to be very careful with that. You're not just talking about technology here, It's more like an organization-wide change, that you're going to be doing actually. So it will be touching your people and processes, it will be touching your infrastructure and technology, and it will also touch your architecture and design, So it's more than a piece of software. It's just not like we're going to stop using this one integration platform and we're going to move to another integration platform. It is more than that, and you have to be careful with that. Okay, so moving on, how can you really think about how can you implement this Agile integration? What tools and technologies one can use actually. So we're going to look into what we recommend or we suggest as Techader is this, what we call Agile Integration Toolset, And this Agile Integration Toolset is built on the open source tools that are available for anyone to utilize. And this is composed of 4 key areas. The first one is the integration platform, or like which we call distributed integration, And I don't want to call it platform because you can include the integrations as part of like in small microservices, So what we recommend or we use is Apache Camel, which is a lightweight, pattern-based, event-oriented, and community-sourced integration platform. Then definitely you're going to host your integrations, and this is where we recommend or we suggest or we use is Kubernetes. And Kubernetes lets you actually build and run and auto scale and all those things it offers you out of the box. Then it talks about APIs, okay, how we can have our API management, and here we recommend to use Treescale, another open source but very nice and well-defined API management solution. And then I'm pretty sure most of you know about Kafka is a really nice tool for event streaming. So if you kind of put up these technologies together along with your tools and processes, you can build up what we can call an agile integration platform. So then if you would say, okay, how would my integration look like, if I start using these tools and technologies? So that's this diagram kind of typically I would represent, So your discovery for integration will be handled within Kubernetes out of the box, invocation, also Kubernetes, and it can be Apache Camel, Elasticity by Kubernetes, resilience, Kubernetes and Apache Camel, pipeline you can run in Kubernetes, authentication, you can use Istio running on Kubernetes, logging, you can run like tools inside Kubernetes like Fluentd, Kibana, Elasticsearch to have logging. Similarly for monitoring, you can run things inside Kubernetes, including Prometheus to have a full insight of your integrations. For tracing, you can run Istio inside Kubernetes and also with Apache Camel. And then for API management, you can use Apache Camel along with the 3-scale API management platform. So these are like some of the concerns that I have mentioned here in this diagram that can be taken care of by different tools in this tech stack. So some of the concerns might be missing here, or you can use some other open source tool here to fill up that concern. But the whole idea here is that you can use these open source tools to build up your really lightweight next generation integrations. So then comes to what is the benefit of this approach, why should you use this approach? So it's like how we think, like moving away from a monolithic ESB architecture, which is more like centralized deployment, we go towards what we say agile architecture, which is like a fine-grained, we're going to integrate where needed across cloud, SaaS, and on-premises, like agile setup. Then you're moving away from point products or limited capabilities to more like a really hybrid integration platform. You can build and integrate across application, APIs, and data, And then you're moving away from a centralized integration team, which is like a siloed and specialized skills, to a decentralized ownership, So your like teams can take care of integrations themselves. And this has been like recorded, I would say, by different companies. Like, this can definitely result into, I would say, 3 times reduction in your integration cost, but you can have a 3 times faster in the creation and in the deployment of the integrations. So you get a lot of benefits for moving towards this kind of architecture and solution. But remember, as I mentioned before, it's not just about the technology. If you will start using like Apache Camel with Kubernetes and Kafka, it will become an agile integration platform. You remember the things I talked about is about people and the processes. They are very important, The governance and all those things, how this like decentralized team will work, So you have to, I would factor in and take care of all of those things as well, So it's not just about technology, it's everything put together. People, processes, and technology, then you can kind of take really benefit of this new architectural pattern for integrations. So today I'm going to talk a bit about a customer case. So basically, we have been approached by a major shipping company that operates across the globe. And they had like running large amount of integrations, on their setup, and currently they were using one of the leading integration platform in a SaaS model, So they kind of approached us, okay, that they are having some challenges that I will talk about later on, and they would like us to recommend a solution, and help us implement. So the challenges that they were having, like, are one, for example, they had the tool they were using. They had some insane licensing cost, really expensive, and they had the way they were utilizing this platform they didn't have, you would say, complete insights, how the whole things or integrations are working, and they also had a lack of auto scalability, which reduces, the performance drastically in case of load. And they had what you call a fixed payment structure, so where they had to at least bind for a year, and which means that if they want to have the elasticity when they require, it was not possible, So they had to actually buy for the whole year if they have to. It's not like, okay, right now I want to scale up and then I want to scale down. Okay, that's not possible. You have to pay for the whole year. And then they had kind of no control on the resource allocations, like it's more like a noisy integration kind of. If one integration starts taking more, then the other integrations were kind of affected, So as I mentioned, they were using in a SaaS model, like utilizing this whole setup in a SaaS model from the provider. And then they also had kind of, a vendor lock-in problem, that if they wanted to use something outside of the platform that is not supported, it was not that easy, It took, it was quite troublesome work, And they also had I would say, lack of automated testing in their setup. And similarly, they had manual deployment setup, which was resulting in a lot of errors and also in downtime. And they were also lacking some, I would say, proper monitoring system, They didn't have a proper monitoring system in place to look at the integrations, how they are operating, So they had a lot of challenges, but if you look into these challenges, you can put them up into 4 key categories, One is of course, they were lacking auto scalability, scale on demand and then, go back when it's not needed. And then also the licensing model of the platform they were using, that was very, stubborn, You have to buy for a whole year if I just would like to scale up for 1 day in the whole month, And also they had manual processes and so there are different areas, you can see where they had the challenges. It was not only the technology, they also had challenges the way they were doing stuff, the processes, how they were doing testing, how they were doing deployments, and all those things were everything was involved, a very nice case, So they had issues with the technology, just because for the few reasons I mentioned. They had problems with their people, or not people, but they were testing stuff, was not proper, and then deploying. So in every area, there was a greater chance for improvement. So what we proposed to the end customer was when we talked about this to the group, to the top management of the customer, they said, okay, we want to go to the new setup, but we want to go with the solution which is supported by some vendor, So we don't want to go just a bleeding edge, but we want to go to a solution which is also a vendor supported, So we said, sure, no problem. So then they went with the Red Hat Fuse, which is the enterprise ready Apache Camel. And then for containers deployment, they went for OpenShift, which is the enterprise ready Kubernetes. And then they went for 3Scale, which is already by Red Hat, but this was more the enterprise version of 3Scale. And then for the event streaming, they went with Red Hat AMQ, which is enterprise ready Kafka in it. So they went with all the enterprise ready versions of those open source tools. So they get the open source, but they also have a vendor support where they ensure that those open source tools are enterprise ready, and above all, they all work together in harmony. So all of these tools are managed by Red Hat or built by Red Hat. So they were all work very nicely in harmony, And you can put them down together very easily. And then they selected one of the clouds where they wanted us to host, So they actually have Stackator is actually managing the whole of their OpenShift platform on a cloud, and then helping them out with their implementation of the integrations in Fuse, and also using other technologies from Red Hat, including Freescale and Red Hat AMQ. So then the question is, what were like the advantages, of going towards this setup, And I think, given the pain points and the challenges we talked before, the benefits were like quite in line with all the areas, the issues they had with, So they had issues with, like, as I mentioned, with auto scalability. So this solution was very nice, auto scalable, because we were running it on Kubernetes. We had auto scalability enabled. So if an integration was starting to get more load, we could actually spin up more instances of the same integration. So which means they can easily auto scale on demand and then scale down when it's not required. And then this is very nice pay-as-you-go model. So you don't have to bind for the whole year. You can just bind for, you could pay for a monthly, and then you can utilize, And in this case, Stackator is managing their whole integration platform on a cloud. So they can just pay for what they're using, So which is like very different from what they have been for paying for the whole year. And then, due to complete control on system resources, like now the developers have a complete insight, okay, how the integration is performing, because we're running it on Kubernetes, OpenShift, and we have a built-in monitoring stack with Prometheus, and the developers have complete insight, okay, how things are working, how things are performing. Then they also have, automated deployment of the integrations. So like now they are using built-in Jenkins within OpenShift to be able to build and deploy the integrations, which definitely, I would say, eliminates the human errors. And then above all, it's like a cloud-native architecture. So we're using all the best practices, using Fuse in Spring Boot applications to build the new integrations, and then deploying them via pipelines within OpenShift, and taking care of all the new features with cloud-native architecture. And then a lot of, I would say, automated testing that we help them support with, so that they can write use the different testing platforms, both for unit load and stress testing, And then, we actually kind of, looked everything as code, as those kind of paradigms, that they can really take value of this new stuff, So not just about technology, but also about the processes and the people, how the things work, And then, of course, we have deployed the complete observability stack on OpenShift, which comes out of the box, including the logging with Fluentd, Elasticsearch Kibana, and then monitoring with Prometheus and Grafana. Then also the tracing stack with Istio, Jaeger, and then also alerting stack, which comes with Alert Manager, So they have a complete observability stack, everything built into the platform out of the box, and they can take the advantage. So this definitely resulted in, having a lot more developers' productivity, and also I think lots of cost savings, in terms of licenses and stuff like that. So I think then also this also results into, I would say, more like a really simplified architecture, which makes it easy to kind of, I would say, manage resources and the whole setup in this new platform. So that's it from me today. I would like to thank you very much for everyone who listened to me today on this topic on Agile Integration. We will be very happy if you are looking into modernize your integrations, and if you'd like to have a discussion with us, please feel free to approach us. Thank you very much.
And thanks for that, Rashid. And I suggest we jump right into the questions. And I address the questions to you here, and I think that Rashid will answer the questions in the comments field himself. But we start with one question here. Do you see any downside with a decentralized approach to integration?
I perhaps can answer that. It depends a little bit on how you see centralized integration as a concept. I would say that, the important thing for agility is that each team is responsible for their own integrations. That doesn't mean that they necessarily need to run their own integration platform or manage the management of those. If you look at, for example, many regular API gateways, you have perhaps a central management platform around that where you actually manage the APIs, and you have decentralized processes running those API integrations. And you can also work with so that the team has the possibility to deploy their own APIs to this platform, and then they are run by the platform. But it's still the team that controls these integrations instead of having a central team working with all the integrations, so that all the integration requests need to come to them for them to develop. That would be a problem, but otherwise it won't be a problem, because you can handle all the security and the governance around that in the platform itself, without taking away the possibility for the teams to interact with the platform.
Do you also agree, August, with Daniel?
No, I agree. I mean, it's about flexibility, really, I would say. And if you do it like that, you get both the stability and governance that you maybe need for managing the platform, but also the flexibility of the organization. So it sounds good.
Yes. And we have another question to you, Philip. Do you have any comments on the intersection of integration and ETL from the analytics perspective, of course?
Yeah, as both me and Christian were talking about, there's many different ways to ingest data into the cloud. And it's up to the user to find the best solution for the type of data you have and type of data integration you need to do. It's many ways to go about it. I don't know if that answers this question, but that's what I would say.
Okay, yeah, thanks. Here is another question. Daniel, could you clarify the difference between AMQ streams and Kafka?
Yes, I can. It's almost the same thing. The AMQ streams is actually the Red Hat packaging of the Kafka offer, so to say. So it's based on Apache Kafka, but it's packaged in a way that Red Hat supports.
Yes, and I think with that question, it's time to wrap up this evening. I would like to say thank you to all of you guys in the panel, and also to you guys that have been followed us the whole evening. Great to have you with us. And I would just like to remind you that if you are interested in any of the materials from tonight, we are happy to share that with you. You can just send me an email at eric.forslid@forefront.se, and I will help you with that. But before we wrap up, I can just give you a teaser that we will host another meetup on the 3rd of June with the theme of with the title, Fast, Scalable and Secure Frontends. So, and you all are very welcome to that. Stay safe, everyone, and see you next time.
Thank you.